Hi viewers, you welcome back to class. This session I'll be teaching bearings. Bearings are angles that are measured from north in a clockwise direction. They are always written in three figures. Bearing are angles that are measured from the north in a clockwise direction and are always written with three figures. They are commonly used in navigation, particularly nautical navigation. If we are given a bearing, we can find the reverse bearing by adding or subtracting 180 degrees from it, depending on whether the original bearing is less than or greater than 180. I have some examples on board, and by teaching this example, we're going to get some more knowledge about how to solve questions on bearings. Okay, the example on board. Given the bearing from A to B, calculate the bearing from B to A in each of the following. Fine. We have two bearings on board, and we've been given the bearings from A to B in each of the two bearings. So, the bearing from A to B in the first one, the bearings from A to B can also be written as the bearing of B from point A. Okay guys, given the bearing from A to B, we are asked to calculate the bearing from B to A. So what I'm trying to tell us is the statement bearing from A to B can also be written as the bearing of B from A. This preposition from is very important in bearing. It's a kind of preposition that is commonly used in bearing. It's very important. You have to understand it, and you have to know how to maneuver your way in using from. It's very crucial in bearings. So what will have bearings from A to B, bearing from A to B can also be written as the bearing of B, the bearing of B from point A, the bearing of B from point A. So bearing from A to B is the same thing as saying the bearing of B from point A. And viewers, let's check it out. Bearing from A to B, from point A to B, you have the four cardinal points here: north, south, west, east. So in bearing, you move to the north in a clockwise direction. In bearing, you move from north in a clockwise direction. So moving, bearing from point A to B, we move from north of point A to B. And so that is the bearing from A to B. And it's also the bearing of point B, the bearing of B or point B from point A. In other words, we are trying to give the bearing of B, a particular point B, and the journey is from point A. So from is a very, very important preposition that is being used in bearing. Okay, now I want to go into the calculation itself now, how to now calculate the bearing of A from B, because that's what we have to calculate. Calculate the bearing from B to A. So the bearing from B to A means calculate the bearing of point A from B. Bearing from B to A, it's also the bearing of point A from B. The bearing of A from point B. The bearing from B to A is the bearing of A from B. But I want to do it in a diagrammatical way. I just don't want to give us the answer, but I want to draw it, and from the drawing explain what the answer should be. Okay, viewers, this is the bearing of B from point A. Now we want to calculate the bearing of A from point B. So we establish the 4 cardinal points here. This is north, south, west, east. For bearing, we're going to move from the north clockwise. So from point B, getting the bearing of A from B now, we move from the north of B clockwise to get to the A, So what we want to find now is the angle from B north clockwise to A. That is the bearing from B to A. Bearing from B to A. Now I want to explain something to us. As we have this 45 degrees here as the bearing of B from A. The bearing of B from A. This is the bearing of B from A. You discover there is an angle here. It is called the co-interior angle C. The angle here is the co-interior angle C, and it adds up to be equals to 180 degrees. That is, this co-interior angle C with this 45 degrees angle here, they add up to be 180 degree. But the full turn angle at the point is at 360 degree. So if this core interior angle C here add up to 180 degree, it means we're going to subtract 45 degrees from 180 degrees to have 135 degrees here. So if this is 135 degrees and we are to calculate the bearing of A from B, or the bearing from B to A, the bearing from B to A, or you call it the bearing of A from B. Either way, it's going to be what we have here. The full turn is 360 degrees, so we'll subtract 360 degrees, we subtract 135 degrees from 360 degrees. With the subtraction, we're going to have 5 here, we have 2 here, and we have 2 here. The answer will be 225 degree. So the bearing from B to A is 225 degrees. There is another method for getting the bearing from B to A, or you call it the bearing of A from B. The other way of getting it is, since we have this bearing to be 45 degrees here, the bearing of A from B, the bearing of B from A, rather, the bearing of B from A to be equals to 45 degrees. So the bearing of B, the bearing of A from B is the reverse bearing. And in that case, since 45 is not up to 180 degrees, we're going to add 180 to 45 degrees and get 225 degrees. I want to explain again. The other way of calculating the bearing from B to A is by looking at the bearing from A to B. The bearing from A to B is 45 degrees, and the bearing from B to A is the reverse of the bearing of A to B. And I told us in the few concepts I gave, the note I gave before I come to working example, I said if we are given a bearing and we are asked to calculate the reverse of that bearing, if the bearing given is not up to 180 degrees, the reverse we are asked to calculate will be adding 180 degrees to the one given. And if the one given is up to 180 degrees, it will be to subtract 180 degrees from what has been given already. In other words, if what is here now is more than 180, the reverse bearing of it will be to take away 180 from what we have here and get the one we are asked to calculate. But in a nutshell, not to complicate the issue, the bearing first method I use is using the co-interior angle C method. By the co-interior angle C, we add up to be 180, and from there I establish the angle here, C here, to be 135 degrees. Since the full turn is 360 degrees, take away 135 from 360 degrees, we will be left with the bearing from B to A, the bearing from B to A, which is 225 degrees. Another way of calculating it is, since we have the bearing from A to B to be 45 degrees, the reverse bearing, which is the bearing from B to A, will be to add 180 degrees plus 45 degrees and get 225 degrees. Simple. I think that's good. I move to the second example, the second one. Under example 1, the second one to do there is the bearing, also the bearing from A to B. And that bearing from A to B is 240 degrees. The bearing for the second question now, the bearing from A to B is 240 degrees, but I would like to draw it again and explain how to get the reverse of it, which is the bearing from B to A. This is the second one. We've been given the bearing from A to B, and the bearing from A to B is 240 degrees. Bearing from A to B is 240 degrees. So I will now move to the other page now and explain how I'll calculate and do it on a diagram, how to get the bearing from B to A. This is the bearing from A to B. I want to establish the one from B to A. Okay, this is the second question, and this is the bearing from A to B, which we can also call the bearing of B from point A. Okay, if we look at the second question now, we look at the diagram on board, we have, this is the bearing from A, this is the bearing from A to B is 240 degrees. The bearing from A to B, or we can call it the bearing of B from point A. Now, what we have to calculate is the bearing from B to A. The bearing from B to A, or we call it the bearing of A from point B. The first thing to do here is to try to map out the 4 cardinal points. You have the north here, south here, west here, east here. So what we are trying to calculate is the bearing from B to A. The bearing, in bearing, we're going to move in the north direction clockwise. So this is the north, and this is the clockwise movement to A. The bearing from B to A, or we call it the bearing of A from point B. Okay, I told us the other time, and it's the faster method of doing it. We got the bearing from A to B already to be 240 degrees. We want to calculate the bearing from B to A. Since what we have here is more than 180 degrees, and this is a reverse bearing, we just subtract 180 degrees from 240 degrees and we are left with 60 degrees. The bearing from B to A is 60 degrees. I'm going to explain it in 2 ways. For us having 240 degrees here, trying to calculate the reverse of this bearing, and 240 is more than 180 degrees, we subtract 180 degrees from 240 degrees and we are left with 60 degrees. So the bearing from B to A will be 060 degree. That is 60 degrees. In bearing, we write with 3 figures. So we have 60 degrees for the bearing from B to A. Another method of calculating the bearing from B to A is the method of the co-interior angle C. The angle here is the co-interior angle C, and it adds up to 180 degrees. In other words, since this is 240 degrees and the full turn of this angle is 360 degrees. So 360 degrees minus 240 degrees will give 120 degrees. 120 degrees now is the co-interior angle C. Mind you, it adds up to be equals to 180. This co-interior angle C here will add up to what is here to be 180. So, to get the bearing from B to A, we can also subtract 120 degrees from 180 degrees and we get 60 degrees. So I've tried to explain it in two ways now. We can use the reverse bearings method or the co-interior angle C method, which add up to be 180 degrees. Thank you, viewers. Do like, share, and subscribe to my YouTube channel. Bye.